back, children. Welcome back to my channel. Myself is Harsha and Kumar. So in the previous video we have learnt about the complete details about the glucose and how to write the straight chain structure of glucose and also structural elucidation. Okay, and also after learning the straight chain structure we have learnt the cyclic structure of glucose. And this cyclic structure of glucose, there are two categories. One will be alpha and other one will be beta. So and also we have learnt our structure of glucose. So by using a small trick 1011. Okay, so today's class, in this video we are going to learn a concept called as after the glucose, that one will be fructose. So this is also very important, and it is a monosaccharide. Okay, it is not a di or it is not a poly, it is a monosaccharide. So always fructose, it occurs in the fruits. Okay, that is the reason this fructose is also known as what? Fruit sugar. Okay, so coming back to your syllabus, okay, there is no structural elucidation of fructose like structural elucidation of glucose. So structural elucidation is not there. Okay, so based on structure elucidation of fructose, okay, the derived straight chain structure of fructose will be, I am going to write it on the board. Just see very clearly, it is very important concept. Okay, so again similarly like glucose, I am going to write 6-member carbon, 1 2 3 4 5 6. So 1 2 3 4 5 6. Clear? So let me put the number now itself. So 1 2 3 4 5 and 6. Clear? Okay, fine. Here in the case of glucose we have written CHO on the first carbon atom, and in the sixth carbon atom we have written CH2OH. Correct? So then we have used the formula 1011. Okay, but in the case of, listen carefully, in the case of fructose there is no aldehyde group. So I am going to erase this one. So what I am going to do here, copy CH2OH, copy and paste here. So first carbon and also in the sixth carbon, okay, there is no aldehyde group. Okay, CH2OH, CH2OH. Clear? So and here in the second carbon atom, okay, double bond O will be there. Okay, so what is this? R bond C double bond O bond R. So this similarly looks like R bond C double bond O bond R. So what is this? It is a ketone, right? If R bond C double bond OH is there, means it is an aldehyde, right? So here if we clearly observes, in the second carbon atom double bond oxygen will be there. Fix it. In the case of fructose there are 6 carbon atoms. Okay, first and the sixth carbon atom CH2OH. In the second carbon atom double bond O will be there. So this almost similarly looks like R bond C double bond O. That indicates this fructose contains ketonic group. Clear? Okay, so now how to fill this one? Okay, so there are this second carbon atom valency is satisfied. Okay, 1 2 3 4. So now we need to concentrate on the third carbon atom. Okay, so 1011 is the formula for the glucose. Okay, so this time I am going to remove a 1. Okay, I am going to remove 1. So what is the formula? 011. 1011 is the formula for the glucose. Okay, if I remove 1, so 011. So 0 indicates what? OH, and 1 indicates hydrogen. Okay, let me apply towards here. Okay, 0 1 1 0 1 1. Okay, if OH is there, here H. If H is there, here OH. If H is there, here OH. That's it. this is the structure of what? Fructose. Fructose is also known as fruit sugar. So this is the structure of fructose. Now, in the case of aldehyde, okay, so let me write this only as a fructose. Fructose. This is the open chain structure of fructose. Clear? Any doubt is there? You can text me. So this is based on this structure. Okay, I am going to write the cyclic form. Okay, so let me erase this part. It will be very comfortable to write over here. Okay, so students, listen carefully. Listen carefully. Double bond oxygen will be converted into single bond oxygen. Already I have explained this concept, how the cyclic ring is going to form in my previous video. Okay, so without seeing that video, it will be very difficult to understand it. But I will tell here. Okay, so very simple concept here. In the case of fifth carbon atom, this oxygen will be activated and it is going to form a bond between the carbon. I mean, it is going to form bond with the carbon. So here oxygen will gain an electron. This oxygen, it is going to satisfied by this hydrogen. Okay, I have not changed in the case of carbon 1, carbon 3, carbon 4 and carbon 6. Again I am writing here, I have not changed in the case of carbon 1, carbon 3, carbon 4 and carbon 6. This is remains same. Okay, I have changed only in the case of carbon 2 and carbon 5. So I have changed. Okay, so for my comfortable zone, okay, so let me consider this C, bond C. So this 1, 2, 3, 4, 5, 6. Okay, so this is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. Okay, so what is going to happen here? Very careful. So carbon 1, there is no change, same. So carbon 1 contains what? CH2OH. Let me write CH2OH. That's it. Okay, so what happened in the case of carbon 2? It is changed. Okay, let me go. 3, 4, 6, let me complete. So carbon 3 is OH. Carbon 3 OH H. So carbon 4, it is same, remains same. So HOH. HOH. Carbon 5, okay. It is going to change. So don't write. So carbon 6, write the same thing. CH2OH. No confusion. CH2OH, CH2OH. So now listen carefully. In the case of carbon 5, hydrogen is there. Correct? Hydrogen is there. Okay. This oxygen forms a bond between carbon 2. So this oxygen forms a bond between carbon. Very simple. Then where is this hydrogen went? This hydrogen, okay, it is going to form with the oxygen. So double bond O. In the case of carbon 2, double bond O will be converted into single bond O, and this is balanced by hydrogen. That's it. Okay, so this structure is known as alpha D minus, this is LEVO, fructose. Okay, so then what do you mean by beta D minus fructose? What to do? This is very simple thing. I think you have understood. Very simple concept here. Okay, so here this is alpha category. Then what about the beta category? Okay, only one thing will be changed here. So here in the case of fructose, only carbon 2 will be varying. In the case of fructose, carbon 2 will be varying. I am going to put CH2OH on the right hand side and OH group on the left hand side. So this product we are going to get it here. C bond C bond C. So 1, 2, 3. Okay. So this CH2OH will be on right hand side. So 1, 2, 3, 4, 5, 6. Okay. So here CH2OH will become. So here OH come towards left hand side. OH. Okay. Let me put the number over this carbon atom. So 1, 2, 3, 4, 5, 6. Rest everything is same. Rest everything is same here. So this carbon atom forms a bond between carbon 5. Rest everything is same. CH2OH. So OH, H, 0, 1, 1, H, OH. So what is the difference between these two? In the case of carbon 2, only small swipe or small orientation has taken. Okay. So this is known as, this structure is known as beta D fructose. Beta D fructose. That's it. This is the cyclic structure of fructose, alpha and the beta. These two are called as anomers, and which is the anomeric carbon here. So anomeric carbon in this case in the fructose will be C2, because in the case of C2 the position is changing. Clear? So very simple concept, nothing is there. Aram se you can write it over here. Okay. So after learning this structure, so we can deal with the what? Overt structure of fructose. How to write the overt structure of fructose. Okay. So just learn this concept very perfectly. If you want to take a screenshot, you can take a screenshot, not a problem. Okay. So here C2. So C2 will be the anomeric carbon. These two are anomers. That's it. Okay. So let me do our structure of fructose. Okay. I will just teach you in the next video. Okay. So without fail, learn these concepts very clearly and perfectly. Okay. Fine. So see you on my next video. Don't forget to subscribe and hit the bell button. Okay. Thank you. Take care.